Now let us see the next block where I'm going to study non-uniform accelerated motion in 1D. Let us see the question based on that. The relation between time t and the distance x is t equals to alpha x square plus beta x, where alpha and beta are constants. So this equation is given. The relation between acceleration and velocity.
So before I start solving this, if you're preparing for JEE or NEET and you feel stuck with concepts, strategy, revision planning, or question solving approaches, then you can check out Pracbee. At Pracbee, students can book personalized one-to-one mentorship sessions with experienced mentors to get individual guidance based on their own strengths and weaknesses. Now with that said, let's get into the question and see the smartest way to solve it.
So we have given t as alpha x square plus beta x, and we have to find the relation between acceleration and velocity. So whenever we have such kind of a question, the first thing is, let us differentiate this, because we have x. So if we take the first derivative of x, we'll get velocity, and the second will give us acceleration. So let me first take the first derivative. So it will be 1, and it will be 2 alpha x times v plus beta times v, right? Now from this we can say v is nothing but 1 upon 2 alpha x plus beta, right? So now let us again differentiate these equations, because we want to find the acceleration also, right? So if we differentiate this, left hand side will become 0. Now we can apply product rule, because we have x times v. So it will be 2 alpha times the differentiation of x will be v. So it will be v square, and the differentiation of v will be acceleration. So it will be x times a, and then beta times a, right? Now from this we can take a, let us take the let us club all the terms which is containing a. So it will be 2 alpha v square plus a times 2 alpha x plus beta is equals to 0. And if you look at this relation, v is equals to 1 upon 2 alpha x plus beta. So 2 alpha x plus beta is 1 by v. So it will be minus 2 alpha v square is equals to a by v. So a will be minus 2 alpha v cube, right? So option 1 is the right answer. Now let us see this question. A particle moves in a straight line so that its displacement x at any time t is given by this equation, x square is equals to 1 plus t square. Its acceleration at any time t is x raised to power minus n, where n is. So we have to find the acceleration at time t. So let us differentiate this 2 times. So we have x square is equals to 1 plus t square. So it will be 2x times v is equals to 2t, right? So from this v comes out to be t by x. Let us differentiate this equation one more time. So it will be v square plus x times a, and that will be equals to 1. So acceleration will be 1 minus v square divided by x, right? And v is t by x. So we can write this as 1 minus t square by x square divided by x, right? And we have to find the acceleration at any time t. So what is x square? Let us simplify this. So can you see it is 1 minus, so I can write this as x square minus t square divided by x cube. Now x square minus t square from this equation will give us 1. So that will be 1 by x cube. So that will be x raised to power minus 3. And 3 is nothing but n. So 3 is the answer. Let us see this question. The velocity of the particle is v equals to v naught plus gt plus ft square, where g and f are constants. Its position is x equals to 0 at t equals to 0. Then its displacement after time t. So we have to find the displacement. So let us so we have v equals to v naught plus gt plus ft square, and we know that dx by dt is velocity. So we can write v as dx by dt. So let me take t on the other side, dt on the other side. Now let us integrate this. And x is variance. So when t is 0, x is 0. and when t is 1, let us say x, and the displacement is x. So the left hand side will be x minus 0, and we know that integration is distributive over addition. So it will be v naught times t plus gt square by 2 plus f t cube by 3, and the limit will be from 0 to 1. So it will be v naught plus g by 2 plus f by 3. So that is the displacement in 1 second. So the option 2 is the right answer.